Imagine a future where Mars isn't just a distant barren planet orbiting the Sun, but a thriving world with rivers, forests, and even cities. This might sound like science fiction, but the idea of transforming Mars into a place where humans could live and thrive, what scientists call terraforming, has been a serious topic of discussion for decades. The concept is both thrilling and daunting. Can we really turn Mars into an Earth-like world? And if so, how? Terraforming Mars involves altering its atmosphere and environment to make it more suitable for human life. It's a concept that goes beyond just exploration. It's about creating a new home for humanity, a second Earth. But the challenges are immense. Mars is a cold, dry, and harsh world with an atmosphere that is only about 1% as dense as Earth's and composed mostly of carbon dioxide. The surface is exposed to high levels of radiation due to the lack of a protective magnetic field, and liquid water cannot exist for long periods due to the low atmospheric pressure. Despite these challenges, Mars remains the most viable candidate for terraforming in our solar system. Unlike Venus, which has an incredibly thick and toxic atmosphere, or the gas giants like Jupiter and Saturn, which are composed mostly of hydrogen and helium, Mars shares some similarities with Earth. It has a day that is just over 24 hours long. It experiences seasons due to its axial tilt, and its surface area is roughly equivalent to all of Earth's land masses combined. These factors make Mars an intriguing target for colonization and terraforming. The first step in terraforming Mars would likely involve warming the planet to allow for liquid water to exist on its surface. Currently, Mars's average surface temperature hovers around -80 degrees Fahrenheit, -60 degrees Celsius, with even colder temperatures at the poles. Warming the planet would require increasing the thickness of its atmosphere, which in turn would trap more heat from the sun, much like how greenhouse gases warm Earth. One of the earliest and most well-known proponents of Mars colonization and terraforming is Dr. Robert Zubrin, an aerospace engineer and author of The Case for Mars. Zubrin has proposed several methods for increasing the planet's temperature, including the release of greenhouse gases such as carbon dioxide, methane, or ammonia into the Martian atmosphere. These gases could be introduced by mining them on Mars or importing them from other celestial bodies in the solar system. However, the logistics of transporting vast quantities of gases across space or conducting large-scale mining operations on Mars are beyond our current technological capabilities and would be incredibly costly. Another proposed method is to use giant space mirrors to reflect sunlight onto Mars, concentrating the sun's rays to warm the surface. This would require constructing massive mirrors in orbit around Mars, a feat that is currently far beyond our engineering abilities. Additionally, while this method could warm certain regions of Mars, it wouldn't necessarily address the problem of creating a thick atmosphere that could sustain liquid water. Despite these challenges, recent research has provided new hope for those who dream of terraforming Mars. A study led by a team of engineers and geophysicists from the University of Chicago suggests a novel approach, using nanoparticles made from materials already present on Mars to warm the planet. This method is both innovative and promising, as it leverages resources that are already available on Mars, potentially reducing the need for expensive and complex operations to transport materials from Earth. The team, led by Dr. Samaneh Ansari, proposed that nanoparticles made from Martian minerals like iron and aluminum could be engineered to absorb and scatter sunlight, creating a warming effect. These nanoparticles would be released into the Martian atmosphere, where they would trap heat and gradually raise the planet's temperature. The team's simulations suggest that this method could warm Mars by more than 30 degrees Celsius, 86 degrees Fahrenheit, enough to start melting the polar ice caps and release liquid water onto the surface. This warming process would also release carbon dioxide trapped in the ice caps, further thickening the atmosphere and enhancing the greenhouse effect. The release of carbon dioxide would not only warm the planet, but also increase the atmospheric pressure, making it more similar to Earth's. While the atmospheric pressure on Mars would still be much lower than on Earth, even a modest increase could have significant effects, such as allowing liquid water to exist on the surface and reducing the need for heavy pressure suits for future explorers. One of the most exciting aspects of this nanoparticle method is its efficiency. The researchers' simulations indicate that this approach is over 5,000 times more efficient than previous proposals for triggering a greenhouse effect on Mars. This increased efficiency means that the scale of the operation, in terms of both resources and time, is significantly reduced, making the idea of terraforming Mars more feasible than ever before. Potential implications and ethical considerations. The idea of transforming Mars into a habitable planet raises a host of scientific, technical, and ethical questions. From a scientific perspective, one of the key challenges is understanding how these nanoparticles will behave in Mars's unique environment. Mars is known for its massive dust storms, which can engulf the entire planet and last for weeks or even months. These storms could affect the distribution and effectiveness of the nanoparticles, potentially reducing their ability to warm the planet. Another concern is the potential for unintended consequences. Terraforming is a process that would fundamentally alter Mars' environment, and the long-term impacts are difficult to predict. For example, warming the planet could lead to the release of not only carbon dioxide, but also other gases trapped in the Martian soil and ice, which could have unpredictable effects on the climate. Additionally, the introduction of microbial life to Mars, while potentially a key step in creating a sustainable ecosystem, could also have unforeseen consequences, especially if the introduced organisms interact with any native Martian life forms, if such life exists. From an ethical standpoint, the question of whether we should terraform Mars at all is a subject of debate. Mars is a pristine environment, untouched by human activity, and some argue that we have a moral responsibility to preserve it as it is. The debate over planetary protection, preventing contamination of other planets with Earth life, is central to this discussion. Proponents of planetary protection argue that we should not alter Mars' environment until we fully understand it and have confirmed whether or not life exists there. Others, however, believe that humanity has a right or even an obligation to expand beyond Earth, and that terraforming Mars could be a vital step in ensuring the survival of our species. The path forward: research, exploration, and collaboration. While the nanoparticle method offers a promising new approach to terraforming Mars, it is still in the early stages of research. The simulations are encouraging, but they are only the beginning. To move forward, scientists will need to conduct more experiments, gather more data from Mars, and continue to refine their understanding of how these nanoparticles will interact with the Martian environment. This research will likely involve a combination of laboratory experiments on Earth, using simulated Martian conditions, and in-situ experiments on Mars itself. NASA's ongoing Mars missions, such as the Perseverance rover, are already providing valuable data about the planet's geology, atmosphere, and potential for habitability. Future missions could include experiments designed specifically to test the feasibility of the nanoparticle method, such as releasing small quantities of nanoparticles into the atmosphere and monitoring their effects. Collaboration will be key to advancing this research. Terraforming Mars is a challenge that goes beyond any one nation or organization. It will require the combined efforts of the global scientific community, space agencies, private companies, and governments. International cooperation on Mars exploration, similar to the collaboration seen in the International Space Station, could pave the way for the kind of large-scale, long-term projects needed to terraform a planet. Moreover, the involvement of private companies in space exploration, particularly those with ambitions to colonize Mars like SpaceX, could accelerate progress. SpaceX's founder, Elon Musk, has been a vocal advocate for making humanity a multi-planetary species, with Mars as the primary target. The development of SpaceX's Starship spacecraft, which is designed to carry large numbers of people and cargo to Mars, could play a crucial role in the early stages of Mars colonization and terraforming efforts. The role of public engagement and education. As the possibility of terraforming Mars moves from the realm of science fiction to scientific reality, it is essential to engage the public in the discussion. Public support and understanding will be crucial for the long-term success of any terraforming efforts, and for ensuring that the ethical, environmental, and economic implications are fully considered. Educational initiatives, public outreach, and media coverage can help raise awareness about the science of terraforming and the potential benefits and risks. Documentaries, books, and even science fiction films can serve as powerful tools to inspire interest in space exploration and to spark conversations about the future of humanity on Mars and beyond. Public engagement is also important for fostering a sense of shared purpose and responsibility. Terraforming Mars, if it happens, will be one of the most ambitious projects in human history, and it will require the collective efforts of people from all walks of life. By involving the public in the conversation, we can ensure that the decisions we make about Mars's future are informed by a broad range of perspectives and values. The long road ahead, challenges, and milestones. Even with promising new methods like the nanoparticle approach, terraforming Mars will be a slow and complex process, likely taking centuries or even millennia to complete. There are numerous technical challenges that must be overcome, from developing the technology to create and disperse nanoparticles on a large scale, to finding sustainable ways to support human life on Mars during the terraforming process. One of the first milestones in this journey will be establishing a permanent human presence on Mars. This will involve building habitats that can protect settlers from the harsh Martian environment, developing life support systems that can provide air, water, and food, and creating the infrastructure needed to sustain a growing population. SpaceX's Starship, which aims to carry the first humans to Mars in the coming decade, will be a critical step in this direction. If successful, these early missions could lay the groundwork for more extensive terraforming efforts in the future. Another key challenge will be the economic aspect of terraforming Mars. The costs of such a project will be astronomical, and finding ways to fund it will be a significant hurdle. Some have suggested that the commercialization of space resources, such as mining asteroids for precious metals or harvesting solar energy from space, could provide the necessary financial backing. Others believe that international cooperation and shared funding, similar to the model used for the International Space Station, will be essential. In addition to the technical and economic challenges, there will also be political and legal obstacles to overcome. As we move closer to the possibility of terraforming Mars, questions about governance, ownership, and regulation will become increasingly important. The Outer Space Treaty, which was signed in 1967 and remains the primary international agreement governing space activities, states that space is the province of all mankind and prohibits the national appropriation of celestial bodies. However, the treaty does not address the specific issues raised by terraforming, such as the environmental impacts and the rights of potential settlers. As we contemplate these challenges, it's important to remember that terraforming Mars is not just about transforming a planet. It's about transforming humanity. It's about expanding our horizons, pushing the boundaries of what's possible, and ensuring the long-term survival of our species. It's about answering some of the most profound questions we face. Can we turn a barren planet into a living world? And if we can, should we? Conclusion: the future of terraforming Mars. The dream of terraforming Mars is one of the most audacious and inspiring visions of our time. It's a dream that challenges us to think big, to imagine a future where humanity is no longer confined to Earth, but has become a multi-planetary species. It's a dream that, if realized, could have profound implications for the future of our civilization and for life as we know it. The road to making this dream a reality will be long and difficult, filled with technical, scientific, ethical, and political challenges. But with new research, innovative ideas, and a spirit of collaboration, we are beginning to see the first steps on this journey. The nanoparticle method proposed by the University of Chicago team is just one example of how scientists are thinking creatively about the challenges of terraforming Mars. As we continue to explore the red planet, gather more data, and develop new technologies, the possibilities will only expand. Ultimately, the question of whether we can terraform Mars may come down to a combination of determination, ingenuity, and a willingness to take risks. It will require the combined efforts of scientists, engineers, policymakers, and the public to overcome the many obstacles in our way. But if we succeed, the rewards could be extraordinary. A new world for humanity, a second home among the stars, and a future where the boundaries of what we can achieve are limited only by our imagination. As we look to the stars and contemplate the future of Mars, one thing is certain: the journey to terraforming Mars is just beginning, and the possibilities are as vast as the universe itself. Whether or not we ultimately succeed in transforming the red planet, the pursuit of this dream will undoubtedly lead to new discoveries, new technologies, and new ways of thinking about our place in the cosmos. And in the end, it may be this journey, the quest to turn a distant, inhospitable world into a vibrant, living planet that defines our legacy as a species. What do you think about the future of Mars? Could we really transform it into a new Earth? Or are we reaching too far? Let us know your thoughts and join the conversation as we explore the mysteries of the universe and the possibilities of the future.